Find the coordinates of the stationary points on the curve y is x into x minus 2 cubed and identify their nature. Well, this looks like a product. We could expand out, but it would probably be a bit of a waste of time. So, u is x and v is x minus 2 cubed. So du dx is easy enough, it's just 1. And for dv dx we need to use the chain rule. So that's going to be 3x minus 2 squared. And the differential of the inside is just 1. So it's just going to be this, 3x minus 2 all squared. So dy dx is going to be v du dx, so that's x minus 2 cubed, plus u dv dx, so that's 3x x minus 2 squared. Now, x minus 2 squared is a common factor, and then here we get x minus 2, and here we'll get plus 3x. So that's x minus 2 squared, and then 4x minus 2. We probably should bring out the common factor of 2 here, so that's 2x minus 2 squared, 2x minus 1. So for dy dx to be equal to 0, this needs to be 0. The 2 doesn't really matter. So that's x minus 2 squared, 2x minus 1 equals 0. So x is equal to 2, or x is equal to a half. Now, if x is equal to 2, y is going to be 2 minus 2 cubed, so that's 0. And so we have the point 2, 0. And if x is equal to a half, y is going to be a half minus 2 cubed. So that's a half, negative 3 over 2 cubed. So that's going to be negative 27 over 8. And with this 2 here, that would be negative 27 over 16. So those are our coordinates. And now we want to identify the nature of the stationary points. Now, if I were doing this question manually, I'd probably now just use a sign test. But we're looking at second derivative test. The reason I would do that is because of differentiating this again. But let's just do it. So we want to differentiate this again. So I'm going to say that u is, I'm going to go from this line here. U is x minus 2 squared, and v is 4x minus 2. So du dx is going to be twice x minus 2 to the 1, and the differential of the inside is 1. And then dv dx is just 4. So d2y dx squared is v du dx, so that's twice 4x minus 2 x minus 2 plus u dv dx, which is 4x minus 2 squared. So this one here, if we take out the common 2, is 2x minus 1 x minus 2, and then we have 4x minus 2 squared. Now d2y dx squared evaluated at x is a half. Well, this is going to give me 0, so the whole of the first term is 0. But a half minus 2 is negative 3 over 2. Square that's 9 over 4. Multiply that by 4 is 9. So positive implies that we have a local minimum. So that's at 1/2 negative 27 over 16. d2y dx squared evaluated at x equals 2, however, so that part's going to be 0, this term is 0, and this is going to be 0, so that's going to be 0. So that actually tells us nothing, and we need to investigate further. So what I would do here is a sign test, and I'm not a big fan of the second derivative test, so I'm going to do a sign test based on dy dx, the same sort of thing we did back in year 11. So we had that dy dx was equal to, so it's these two multiplied together, so 4x minus 2 and x minus 2 squared. So we're just looking at the turning point where x is 2, because that's the one that gives us an issue. And let's see what happens either side of that. What we mustn't do is go past the other turning point at 1/2, but I haven't done that. So we know it's 0 here. So substitute 1 in and we get 4 take away 2, 2, and this one's going to be positive because it's squared, so that's positive. And then for 3, this would be 6 minus 2, so that's 4, and that's going to be positive. So it goes positive, 0, positive, so it must be a horizontal point of inflection at 2, 0.